All series, we've been writing tests and watching them go green. But here's an uncomfortable question to end on. Do those tests actually work? You can have 100% code coverage in a suite that catches almost nothing, because coverage only proves your code ran, not that a single assertion would notice if it were wrong. There's a tool that measures the real thing by trying to break your code on purpose. It's called mutation testing, and it's the most honest feedback your test suite will ever get. Let's run it. Coverage is the metric everyone reports, and it quietly lies. All it measures is which lines of code executed while the tests ran. Here's the catch. A test that calls your method and asserts absolutely nothing still counts as full coverage. Green bar, 100%, zero protection. Mutation testing measures what you actually care about. It takes your code and breaks it on purpose. Changes a less than to a less than or equal, flips a true to a false, deletes a line. And for each of these mutants, it asks one question. Did any test fail? If a test caught it, the mutant is killed, good. If every test still passed, the mutant survived, and that's a gap, a bug your suite would have shipped. The mutation score, the percentage of mutants killed, is the honest measure of whether your tests have teeth. Here's what a mutant actually is. Take a real method. Is this to do overdue? It's active, and its due date is before now. Stryker takes that one expression and introduces small, plausible breakages. It changes the less than to a less than or equal, the classic off by one boundary. It flips the operator entirely. It swaps the and for an or. Each is a separate mutant, and Stryker reruns your tests against each one. Now look at that first mutant. Due date less than or equal. If you never wrote a test for the exact boundary, a to-do due at precisely this instant, then your suite passes against the broken version too. The mutant survives, and Stryker has just found the test you forgot to write. Let's run it for real. This is Stryker.net, a third-party tool, mutating the domain and rerunning the tests against every mutant. Watch the score come up. Each killed mutant is a test doing its job. Each survivor is a gap it just found, a place where the code could be wrong and not one test would notice. That number, the mutation score, is a far harsher and far more useful grade than coverage ever was. A suite at 90% line coverage might be killing only half its mutants, and now you can see exactly which halves, file and line, so you know precisely which tests to write next. And this is exactly why mutation testing matters more now than ever. AI assistants write code and tests at a scale no human can review line by line. That's a huge productivity win and a real risk, because an AI-written test can be the perfect coverage theater. It calls everything, and it meaningfully asserts nothing. So who tests the tests? Mutation testing does. It's the check on the checker. Point Stryker at AI-generated tests, and it tells you, mechanically, whether they actually kill the mutants or just pad the coverage number. The healthy loop is the one we started this series with, now closed. Write the failing test, or prompt your assistant to. Make it green, and then let Stryker prove that test has teeth. Red, green, refactor, and survive. A few practical notes. Because mutation testing is powerful but not free. It reruns your suite once per mutant, so it's slow. Don't point it at your whole repository. Aim it at your critical domain logic, the code where a silent bug actually hurts. In a pipeline, scope it to the diff and set a score threshold, so survivors on the code you just changed become a review prompt before merge. And treat the number as a guide, not a tyrant. Chase the survivors that represent real, dangerous gaps, not a vanity 100% on trivial code. Used that way, mutation testing is the final, honest answer to the question this whole series has been asking. Can I actually trust my tests? That's mutation testing. Coverage tells you your code ran. Mutation testing proves your tests would catch it if the code were wrong. And it's how you keep AI-written tests honest, by making them kill real mutants instead of padding a number. And that closes Series 5. We built the whole pyramid, a broad base of fast unit tests, value objects, railway pipelines, and aggregates, a middle band of integration tests over the real pipeline, the real database, the HTTP contract, authorization, and observability, contract tests across services, your own analyzers, and finally, the test that tests your tests. Confidence isn't a feeling, it's something you engineer, one honest test at a time. Thank you for watching Series 5. Next, in Series 6, all of this graduates to live infrastructure and distributed systems. Subscribe, and I'll see you there.